Next up, we're going to have Dan Roth give a talk. He's the chief AI scientist at Oracle and also a professor at UPenn. He's been a professor for more than 20 years. And at Oracle, he has a bit of a view into everything going on in the AI race. So please welcome Dan.
Okay. Hi, everyone. Really excited to be here. So I'm going to change gear a little bit and talk about data, how we use data, how we access data. And you'll see in a minute why I call this AI for data and data for AI. But mostly, I'm really excited about the promise that Gen AI has for data. So really, we are going to move from the messy world of using a lot of types of data, different representation, different types, where people need to learn the domain, need to learn how data is represented, need to transform data from one format to another, and need to understand how to fuse diverse data to a much cleaner way, where we'll be able to actually work with data in a conceptual level, our own terms, our own metrics. And what adds to this excitement is the fact that really a large amount of data that exists in the world is going to remain outside a language model. So you know, language models have swallowed a lot of the data, and you know, this is why we have powerful agents today. But there's really no more general purpose data. A lot of the general purpose data has been swallowed, as I said, by model provider already, but there is a lot of data out there, data that belongs to corporations, data that belongs to financial institutions, government agencies, people, and medical centers, and this data will stay outside the models. And it's going to be dynamic. So the question is, how do we deal with this external data? And I think that one of the key use cases of Gen AI is going to be that of orchestrating and supporting access and use of external data. And this is true for human consumption, but it's as important when we think about agents using data. Think about your coding agents. In order to develop coding agents, these coding agents need to access a lot of data, from design documents to tickets, maybe to correspondence about what happened in previous generation of the software. They need to access heterogeneous knowledge sources and do something with this. And this is difficult. So reliably supporting decisions that depend on retrieving and using data is extremely difficult. More difficult than we kind of think. And it's difficult for multiple reasons. It's difficult because of information retrieval. Hopefully, this will move at some point. There is a myth that information retrieval works, but you know, try to search your email and tell me whether it does work. Understanding information needs, understanding the stored data, using data, all these are extremely challenging in today's world. And it makes all this business of knowledge access and use very difficult. So in most cases, we are thinking about AI for data, sort of how to use data or how AI can help us to use data for our own human consumption. Ask what AI can do for you. But really, we care about data for AI, because in order for us to develop agents, agents need to access data, to access a lot of different kinds of data. So this relationship between AI and enterprise data is really not one-dimensional. While AI unlocks value from the data you already have, the quality, the structure, the governance of your data really determines what the agents, what AI can actually do. So understanding both sides of these equations are really important, and really the difference between AI that works and AI that may not work. So really the data layer underneath agents is crucially important and very difficult to build. So, so think about agentic capabilities and what kind of data we need in order to develop them. Think about, you know, the 17 different types of documentation that exist. And think also about just trajectory data, operation data, tool use traces, and all this data that your agents need in order to be able to actually do what you want them to do. So why is it so hard? There are many reasons for this is there are some core difficulties, retrieval. Really, information retrieval isn't working unless the way you present the information need is lexically close enough to the way the documents that you care about are represented, which typically doesn't happen. So this actually necessitates developing a semantic data layer across heterogeneous knowledge sources. So first of all, you will bring the representation of the data closer to the way information needs are expressed, but also so that you will not care about where is the data coming from, which data source it's coming from. We need to deal with structure. So people think about NL to SQL or NL to other formal representation, and this transformation is very difficult, partly because it depends also on retrieval. If we want agents to use the data, again, we need information, them to access multiple knowledge sources, and we need expertise for each one of these knowledge sources. We have rich documents today. More and more rich documents are being stored, from papers to figures, to video, to images, and the information inside this rich data is actually not exposed to your retrieval, unless you do something to expose this information, and then maybe some pre-processing, maybe some stuff that your agents may or may not do. As I'll show in a couple of examples later on, planning how to access data, in what order to access it, how to filter one source by another is a very challenging problem, and not to mention conflicting information. Think about your file system or your email, how much conflicting data is there, and we want our agents that access data to actually do something well with this. And of course, there are reasoning challenges. Reasoning, in many cases, is beyond the capabilities of general purpose models. And under all these kind of core difficulties, there's issues that have to do with governance, policy enforcement, reliability, consistency, auditability, that if you want to use large-scale data in the context of a corporation, medical center, and so on, you really have to deal with. And optimization, so in the first generation, we don't care so much about cost, but we do care about cost. And how to think about when do I process data offline, when do I process it at runtime, how do I cache computation, how do I use query logs and history, all these are really difficult problems. So we actually are trying to work on all these aspects of the data, and I'm going to try to give you one slice of this, an important one, but not the only one, from the perspective of NL to SQL. And I'm going to give a shameless plug to some results that some of our teams at Oracle have done in participating in competitions like Spider2 and Archer, and doing really well, kind of leading on top of the leaderboards in this. But beyond the shameless plug, I want to actually point out the absolute results. So you can look at Archer, where the results is actually 55%, or Spider2, where the results is just low 70s, which means that we are really far from being able to address these issues of accessing data and using data properly. And I'm going to illustrate this with the following example that hopefully you'll find interesting. So I'm very interested in tennis, and I follow tennis closely. So I'm using tennis as an example for a lot of the things to kind of show capabilities. So here is a question that I asked just a few weeks ago. I presented to a top model. Give me a list of the European male tennis player sorted by their tennis income, only tennis income. So if you think about it, it's a very complex question because the model needs to know who are the players, which country they're coming from, is it in Europe or not, then go to tournaments they play in 2025, how much money they made in each one. But and the model actually gives me the way it thinks, which sources it goes to, which tables it goes to, which pieces of text it goes to, and at the end it gives me a nice table. Now, first of all, before I analyze the table, think about how cool it is. This is really the promise. I just express my information need in natural language, and the model devised it. He gave a plan, accessed many information sources, structured, unstructured, web, used its parametric knowledge to know where the countries are, and so on, reconciled conflicting information because there's a lot of conflicting information out there, aggregated that and summarized it into a table. Beautiful. Now let's look at the details. Look at these two entries that I point to in the arrows. and you see that they are not sorted correctly. This was the most surprising mistake to me because the model should have called the tool to do sorting properly. Never mind. But even more interesting is someone is missing. I'm sure some of you will be able to tell me who's missing from this list. Alcaraz is missing. So the model forgot Carlos Alcaraz. Not nice. And you can also look at these two players that I point to, and you'll see that their income is identical to the dollar. So they made millions of dollars, and the income is identical to the dollar. Cannot happen. Clearly a mistake. So what's happening here? So really, it's a very difficult task. The model needs to optimize access across knowledge sources. Now, it can go about it through a list of players, generate a list of players, and then figure out whether they are in a European country, which tournaments they play with, how much money they made in each tournament. Or it can go to the list of tournaments, and then look at each tournament, who played there, how much money they make, and so on. Now, there's a lot less tournaments than players, so maybe this should be the right way. But on the other hand, tournaments and data are more noisy. So it really, doing this right, really depends on understanding the data and the domain, which is very difficult. In tennis, it's possible. In most cases, it's just impossible. So while agents are doing this faster than we can, they're prone to errors and high cost. And most importantly, if you think about it, and I did remind the model that he forgot Carlos Alcaraz, and he added Carlos Alcaraz, but if you look at it carefully, you'll see that a few other things change. For example, Andrei Rublev, number 7, completely disappeared from the new list. The money changed a little bit, so someone, Zverev, that made over 6 million before, now is making less than 6 million. So it's not consistent. But really the important thing that I want to point out here is this is tennis. Really, who cares? And I also know the results, so I know how to kind of look at it and decide whether it's correct or not. But if this was the same question that you ask about your financial analysis of your company or any other sensitive information, the notion of visibility of failure is really important. We should be able to address this issue because without it, we cannot use these kind of systems reliably and consistently. So I want to stop here, basically remind you that real-world data is multimodal, temporal, multilingual, heterogeneous, and we really have to do a lot of work in order to unlock this information. And understanding both sides of the equations, AI for human consumptions over data, and data for agent consumption, or using data for agent consumption, is really the difference between AI that works and AI that disappoints. Thank you.
All right. Well, so we're very lucky to have this group here. A lot of the people here are responsible for the way AI looks today in the real world. And everyone here is also working on how it should look in the next couple years. So I think this is a wonderful opportunity to have this discussion. We're not going to shy away from the hard questions. So I guess the first one is, maybe just to start high level, like, do we have the right architecture to get to this next level of AI? Do we have, are transformers the right thing to get to RSI, continuous learning? I think I want to start with Jerry on this one. Let's start here.
Okay, it's a spicy one, but I feel like I'm being asked a lot about it. And my theory of AI research is that you always should try to think, what is the bottleneck of the day? What is the thing, why are today's models not 10 times better than they are right now? And while doing what we've been doing and keeping investing in transformers, building new environments, scaling up training, gives us gains. Those gains are predictable. We already know how to do it. I think architecture is the biggest thing that can give us gains beyond those things that we already know how to do. I genuinely believe, and record this, remember that the next 2 years will be the time of architecture, where the biggest gains and the biggest progress in the deep learning will come from like trying to step away from the transformers. We have been the discovery of transformer has been an inflection point for AI research. Like scaling transformers and doing pre-training has been another moment where the age of scaling has started. But transformer has carried us very far, and I think it is kind of like a little bit like holding us back right now, where I believe for the same cost you probably can train much better agent with a different architecture. We just don't know that architecture yet, and it's a time to find it. That's what I think.
Oriel, you guys are working a lot on, as you just said, RSI. Do you think transformers are the right thing to get us there?
Well, first of all, I guess transformers have transformed over the years. So, like, if you look at the actual model today, it resembles, but it's not the same. So every iteration of a new model we see outside, especially the ones you can also see in the open source, I mean, there's a lot of tweaks in the architecture already happening. So definitely there's a hill climbing, perhaps to Jerry's point, is a bit of a local optimum around the transformer, but that's very important. I'm not sure I would believe that I mean, is there a better transformer-like thing that is much more efficient? Possibly. I feel like when I think of architecture, I think holistically, not just the brains, but also the whole agent that you build around it. That architecture, I feel, has a lot of more low-hanging fruits to optimize, like its memory system, how it compresses context, and so on. So I would probably bet on disruption there first, although I'll be rooting for, obviously, better architectures that I'm sure they'll publish in NeurIPS 2027 or so.
No comment there, I guess. Dawn, I'm curious for your thoughts on this.
Oh, yes, this is a very good question. I was talking to Jerry earlier. The question is, which way will go faster? Yes, I think potentially there ought to be some other architecture there that will be more effective than transformers. The question is, how far? So we have two paths. The one is we continue down the current path with transformers, and I think a number of people here are working on RSI and so on. So then with RSI, as even with the current path, the AI can continue to improve, and then with RSI, then it can help potentially to find better architectures. Then that's one path, and another path is we have humans, we have experts like Jerry to try to discover, design new architectures. And the question is, which path will get us sooner there? Especially given that I think we can also do a poll here for people to think like what everyone here thinks about the timeline. Like when are we getting to RSI with this path? And I'm actually very curious to hear.
Okay, well, let's do a poll. So who thinks we're going to get to RSI this year, 2026? 0. Okay, so RSI 2027? Hands go up or down. We can't do. Okay, 2028. Okay, 2029.
So I don't.
20. Any hand? Maybe you need to say the year. What year do you think RSI is coming?
So I'm not going to make a prediction because I think this is not necessarily the key question when you ask about whether the technology is ready for something. So we are in an agentic summit here. And why do we move to agents? I mean, one reason we move to agent is really an admission by model providers and everyone that we cannot think about just models, we need to think about systems. So when we think about systems, today we are still coupling an agent with a model, but that's going to change. I mean, so we're going to decouple agents from models, and the architecture is going to change also at the model level, but the system level is the one that I think is more important because people realize that we have to be able to delegate, we have to use solvers, we have to use experts models and so on. And to me, the key differences are going to happen at that level. And over time, transformers also are going to change, right? So transformer is a very, very recent beast. There's no reason that in 10 years this is going to be the component that we rely on. But still, the questions that are around kind of how to build intelligent systems with solvers, with expert system, and so on, that's going to stay even when we change the underlying architecture of the model itself.
Yeah, I have some questions for that too. I think this is also another question for debate is, one, how much of the power or the differentiation is at the model level versus actually at the agent level? And also, so we have been doing some work, I think, like others have been doing this work as well. So as the model becomes smarter and smarter, so right now, when people build agents, there's still a lot of human design. Yes, we talk about memory systems, compaction, and all these different things. You still have humans design this. But as the model gets smarter, the model essentially can build agents themselves. So we actually recently developed open framework, agentic framework. We call it AI-centric agent development framework, where we have the model to actually build agent itself on the fly. And build all these different components and so on. And as the model gets smarter and smarter, it actually can do this very well. So then it also begs the question, then going forward, whether we actually still need to build these. Yeah, here we are at the Agentic AI Summit, but there's a question whether even next year, what are we going to do? Are we just going to have models to actually write the entire agentic system framework and so on?
Wojciech, I'm curious for your thoughts on that.
So, few things. So, there's a question about what's the mental model for the AI development. And you might think that maybe AI development is like stacking up a Lego piece after piece, that is actually not even that hard to make an improvements in the, let's say, the memory piece, or like having architectures more efficient. It's just like you keep on stacking it up, and models become better and better. Or alternatively, you might be thinking that actually doing AI research is similar to developing relativity theory. You need this like a genius, like a massive brain to come up. So far, historically, we have seen that primarily we are in the world #1. There has been few instances of these like breakthroughs, like a transformer, as people mentioned, but still we can keep on hill climbing, building Lego piece one after another. And it seems that the models might reach the, you can call it, escape velocity. So in some sense, they can be good enough such that they can continue stacking up the Lego pieces. So, you know, you build a model that gets 150 IQ, then you get 200 IQ, 250 IQ. Of course, there's a question about the asymptote, if that would continue. And it might be the case that if it continues for sufficiently a long period of time, it's like if it keeps on improving, then even if there are some necessary breakthroughs needed, then the good enough model might crack them. So now, whether or not the escape velocity would be achieved, like whether or not there is like enough energy put into the system, that's the question. Or like when would that happen?
Weiju, I'm curious for your thoughts on this kind of, you know, system versus, you know, the core architecture kind of debate.
Yes, I think for the I side, basically, it highly depends on, just like you say, the system, including this kind of the IL environment, the evaluation, which kind of task you want to solve. I think from the model point of view, as long as you are able to specify the task very clearly, but I think this is pretty challenging. It's the most difficult part. And it's easier for the model, for the ISI trying to, okay, specific to this task is doable in the next 2 or 3 years. But you want to say about, okay, it need to be very generic. I think it's much, much harder, maybe it's 100x harder. So there's a huge difference. Yeah, from the architecture point of view, I think, in my opinion, is about architecture finally is still defined by the model capacity, how many parameters you have in the architecture, and yeah. So nothing is for free for the architecture. Definitely not free lunch. When you get something good, it's going to sacrifice the other part for a lot of cases. Yeah.
Yeah. I mean, I think just to kind of move the conversation along a little bit just with our time, I'm curious also, like there's been this incident recently in the last couple of weeks of, that's really brought to light how much security and safety is so important with agents nowadays. Like, we might not have RSI today, but agents are very capable. We've seen, OpenAI's agent hack Hugging Face. Anthropic said its agents have escape containment too. And maybe, Don, I'm curious for your thoughts based on your security background. Like, I'm curious what you think, how these incidents shifted your thinking about safety and security with agents.
Okay, great. Yeah, thank you. Thanks for the question. So first, I actually want to clarify some things. So first of all, actually, in the OpenAI's case, what the agent was trying to do, it was tasked to actually solve tasks in the benchmark explosion, which is what we developed. And there have been various blogs written about it. I want to take the opportunity to clarify a few things. So first of all, that explosion, the OpenAI deployed explosion in their internal infrastructure, and so that's their internal deployment. And also, so what the agent did was somehow the agent figured out, oh, maybe in order to solve the tasks, maybe Hugging Face has some data or information related to this. So I decided to go to Hugging Face to try to find this. And then actually before this incident became publicly known, we actually got an email from Hugging Face asking us, oh, so we also developed another benchmark called CyberGym. So CyberGym and ExploitGym, they actually cover the entire life cycle for vulnerability, like a vulnerability discovery and then exploit generation. So we actually got an email from Hugging Face asking, oh, there's a CyberGym, essentially serving points, and they seem to have some vulnerabilities. Asking us, do you guys know this? And then we looked into this. We said, oh, actually, this is not our CyberGym. So basically, some third party deployed some service on Hugging Face, and they also called it CyberGym. I think they copied probably some things from the CyberGym benchmark, but they called it CyberGym. And then in the end, that's actually what the agents was able to exploit, and then through that, and then got into Hugging Face infra and so on. So I wanted to clarify that even though that one was called CyberGym, but actually is entirely a third-party deployment, has nothing to do with us. So we actually clarify with the Hugging Face, for their blog and so on. But anyway, so this I think is a wake-up call. Even though my group, so we have been among the earliest to actually investigate in this space, looking at the impact of frontier AI in the landscape of cybersecurity. And we did all this work. Also, I was trying to essentially raise the awareness earlier for the community to get prepared and to take action, because I could see, even, we started working in the space actually 2 years ago. Even then, I could see with the AI fast progress and so on, this is what's coming. Although actually I had to say, even though we built out this benchmark and demonstrated, and I was trying to talk to people even in the policy space that we need to get prepared, but I think it was difficult for people to really understand and get the message. So I think what happened was some mythos certainly helped. And also I think this incident really is a wake-up call for people that the agent's capabilities now have reached a level.
So I want to say that it's clearly a wake-up call, but I think we shouldn't think that this is only the cybersecurity problem. This can happen everywhere. So we saw earlier today the Tetris example. But imagine that you have a multi-agent system, and the agents communicate among themselves, and you impose some constraints on what information they can communicate to each other. So Dawn doesn't want some of the information that her agent has about her to be communicated with Mac's agents or my agent. Now, we can put a verifier that verifies that they don't break these these kind of rules of what can be communicated, but the agents can go around it and maybe change the language that they're using so that the verifier is incapable of verifying what they're doing. So this issue goes much beyond just cybersecurity. It goes to any communication system that involves agents, and we have to really think about it from kind of from basis, what are the issues that we have to deal with? And I think we are a little bit dormant in this space.
Yes, absolutely. I think, yes, the risk is vast, covers a broad range. And I think in cyber in particular, I think just given that already we know there's huge incentives for attackers to attack, and now really with frontier AI significantly reduced their essentially costs and also the expertise level that's needed and so on. So this can really bring a huge sea change in the space.
Wojciech, from a resilience perspective, what do you think?
So I was thinking, what's the mental model of what's happening now? And maybe one mental model, so okay, it doesn't seem that what just happened is like a last incident. Okay, that doesn't seem so, okay? Quite opposite, it seems that we are entering a new era, okay? So maybe one way to think about it is imagine what happens if all of a sudden locks to the houses stop working, okay? You can just enter every house. What happens, okay? So that's that's the era that we are entering with cybersecurity. We should expect in the very close future that the open source models will become insanely good in cyber, and that will be a problem. That will be a problem for critical infrastructure. It will be a problem both from perspective of teenagers hacking for fun, people who are motivated to hack for the gains, and also nation states, and all of these will be at play. My guess is that it will be chaotic.
Mm-hmm. Any other thoughts from the panel here?
I think like cybersecurity is one angle. Definitely, we probably already live in the world where like we are lucky that OpenAI and Anthropic are good guys, but they probably can hack any company in the world if they want to, which is a scary realization. But there's other angle from a perspective of reinforcement learning researcher, which I am a little bit worried, which is misalignment and reward hacking, which we have seen there and escaping the sandbox. And that's something that everyone who works on reinforcement learning, I would like them to be really care about and really worry about, because in some ways we are training those models to get reward in various environments and various situations, and it's up to us, the researchers, the trainers, the people building that systems, what is actually rewarded. And whenever we are building an environment where the model can hack, where the model can do unethical things, the model can do incorrect things to get reward, the model will do it, the model will learn it, the model will express that behavior in the real world. And we are putting more and more of our life in the hands of the models, and we'll be only doing more and more. AI is great and everyone is using it. And the reward hacking models, if they are exposed to the real world, they will be doing things that are not great, and they are trained for that by us. So like designing your environments in a way that promotes the right types of behaviors and the right types of taking actions is what really everyone should be doing. And I think there almost should be like some standards. You don't get to train your models if you don't build your environments carefully enough, because we don't want to be having misaligned models everywhere that are trying to exploit whatever sandbox they are in to get the reward. It's a really scary thing to think about.
Well, on that note, we are out of time, but thank you to the panelists for a great conversation. If we get a round of applause for the panelists. And thank you so much, everyone. Appreciate it.